All right, so let's say given this diagram and they say the maximum force of friction when you pull the object is 230 newtons. And the questions ask you, what is the force of static friction if I only apply 50 newtons on the object? So we can start off by drawing a free body diagram. So we have the weight and the normal force, and we also have the force applied. Then we also have the force of static friction, Fs, which is our force friction due to the force applied. Apply an equation here, Newton's second law, convert it into the Newton's second law in the x direction formula. Since our force applied and force of friction is going to be in this direction. And if we look at our diagram here, we're going to have the force applied and the static force of friction. And then we can define the right direction as positive, so we get this expression here. From here, we can know that the acceleration is equal to 0 because the mass is not moving. And if the mass was moving, it would no longer be static friction, so it wouldn't be Fs anymore, it would be Fk, which is the force of kinetic friction. So then we can plug that in and get this expression here, and then we can bring Fs over, and we get this final answer. This is going to be our force of static friction due to the force applied. We can draw this situation here, so we have our force applied 50 newtons, and then the force of static friction, which is also 50 newtons, and this makes sense. Since the mass is not moving, the forces have to be in equilibrium. Note, the force of static friction is not always equal to Fs max, and that's just what I wanted to show in this example. Our force of static friction is 50 newtons, and Fs max is 230 newtons. They're not the same, but the force of static friction that we found is less than Fs max, so it still agrees with the equation for static friction here.